Hello everyone. In this video we will discuss a problem on uniform cost search. Uniform cost search is an uninformed search algorithm usually used when the step costs are not same. We have seen that a uninformed search algorithm like BFS is optimal and pursues the shallowest nodes in each layer, and but the basic assumption in breadth first search is that the step costs are all same. But when the step costs are different, we have uniform cost search, which will allow us to find the best path from the initial node to the goal node, which has the least total cost. So in order to maintain these costs, we use a data structure called as priority queue, where based upon the nodes which have the lowest path cost, we try to pursue them and see if it reaches to the goal node. So to demonstrate it, we'll have this example. Consider this example where we have 5 nodes. A is the starting node and G is the goal node, and our job is to find out the best path from A to G. As you can see, there are 2 different ways we can achieve, and let's see how we can apply uniform cost search for this particular problem. So in the beginning, we have, as discussed in the theory, we have both open list and closed list. Open list also called as frontier, which contains nodes which are yet to be pursued, and closed list contains nodes which have already been pursued. So let's start with the first node, which is A. So as you can see, there is no cost incurred because we haven't taken any step yet. So once it has been placed in the open list, we take it to the closed list and generate its children. So currently A has been moved to the closed list, and if you see the children of A, we have B and C with path costs as 80 and 99. And this is a priority queue, and we try to maintain the nodes which has the least cost in the top, so that will be pursued later. So as you can see here, B and C, among B and C, B has the lowest cost, which is 80, and C has the path cost as 99. So B will be pursued first and later C. So now after generating the children, we will be considering B as the node to be pursued, and that will be placed in the closed list, and we generate the children of B, and we can see here there is only D as the child node for B with path cost as 97. So the total cost at D is 80 plus 97, which is 177. So this also will be placed once again in the open list for it to be pursued later. So as of now, the next important or the next node which to be pursued is C, because it has a path cost of 99. So this will be placed in the closed list, and its children are generated. As you can see, G is the children for node C. The path cost incurred for node G is 99 plus 211, which is equal to 310. But we don't stop when we reach to the goal node. In uniform cost search, we will try to search for all the other paths and see if there is any better path which can incur a lower cost than the current path to the goal node. So we don't stop here. It's only that we place this node in the open list, so G with 310 as the cost, and later we try to pursue the next node, which is D with 177. So when you try to place this in closed list and expand its children, so we have G as the child for node D, and it is incurring only the cost 278, which is very less as compared to the previous cost of 310. So that G will be updated to the new path cost, which is 278, and if there are no other alternative path to reach to the G, then we will say that G has reached to the optimal solution. And the path, we trace the path, we keep record of the paths from where it has been generated. So therefore we finally identify the path from the initial state to the goal state, which incurs the lowest cost. So this is how uniform cost search can be applied for such a problem. So basically it will try to find out the best path which has the lowest cost. So and also one important thing is the uniform cost search is a kind of variant to the Dijistra's algorithm. If you see the Dijistra's algorithm, we try to find out the shortest distance from a source node to all the nodes, whereas here we are interested in finding out the shortest distance or the lowest path cost from the starting initial node to the goal node. So both are similar in the way they work, except the slight implementation differences. So this is how uniform cost search works.